Yeah. Hello, everyone. Welcome to IMS GATE Academy. Can somebody confirm that my voice is audible? Yeah, maybe someone can comment so that I'm sure that everything is fine. Yeah, just this. Yeah, is it audible? Yeah. Can someone confirm that whether my voice is audible or not? So, yeah. Okay, yeah, thank you so much. Yeah, yeah. So, wishing you a very happy Engineers Day. And I'm Amit Goyal. I'm a GATE CS mentor at IMS GATE Academy. And today we'll be covering theory of computation, and we are doing a very important topic, that is identifying the class of the language. So this is a topic which has been asked very frequently in GATE, and in every year you will find that there are almost say around 1 to 2 questions every year on identifying the class of the language. And what we will do is I'll give a brief summary of the topic, and then we will do questions on that, right? So this is briefly the agenda of the today's talk. What we will do is we'll have first 20 minutes to the brief theory we will give. So why we are doing that? So that I assume that a few of the students do not know the concepts. For them, I'm trying to cover the concepts. And after that, in next 40 minutes, what we'll try to do at least 20 questions on the subject. At least 10 questions. So I'll give you 2 minutes to solve the question, and another 2 minutes I will solve the question. So at least 4 minutes for every question. Thereby, we can do around 40 questions on the whole. Right? So yeah. So yeah. So to know that how many students are there, can somebody you can simply say that a hi or something will help, so that I get to know that the students are here. Can people say hi or something? I know Divishri is here, and the Dawalji is here. So others can just say hi or something so that I get to know that they are here. Yeah. Okay. So yeah. Okay. So I think we have the people here. Okay. So what we are trying to cover today is, as I said, the identifying the class of the language. So I'm just giving you a brief summary that what are the various classes of languages that we have in GATE, right? So this is briefly the hierarchy of the languages. We have like 4 types of languages which are heavily asked in GATE. Although there are other types also, but for GATE purpose, we only need these 4 languages. So we have a regular language, we have context-free language, then we have context-sensitive language, and then we have recursive enumerable language, right? So as we see that I have written here that this is a superset relation going from top to bottom. So that means that the recursive enumerable languages, this is the heaviest subset, right? So basically, when I say that this is the heaviest subset, that means that recursive enumerable language is the biggest subset that I have. So this is the biggest subset that I have. And then the regular languages, this is the smallest subset. So what we can say is the every recursive, so every regular language is recursive enumerable, but every recursive enumerable language is not regular, right? Because that is the biggest set that engulfs everything. So basically, these are the various 4 types of languages that we have. Then we have, for each language, we have a grammar for that. So basically, for regular grammars, we have for regular languages, we have regular grammars. For context-free languages, we have context-free grammars. Then we have context-sensitive grammar for context-sensitive languages, and then we have recursive unrestricted grammar for the recursive enumerable languages. Right. So this is briefly the grammars that we have. And these grammars are also known by type 3, type 2, type 1, and type 0. These were proposed by Chomsky, so therefore we call them Chomsky hierarchy. So therefore we have type 3 languages, type 2 languages, type 1 languages, and type 0 languages. So sometimes in GATE they will ask that whether this language is type 3 or type 2 or type 1. So you should know that which language is type 3 and which language is type 1. So this is basically the grammar part. And then we have acceptors. So acceptor is basically the automata which accepts this language. So in general, what we have is we have a language, then we have a grammar which is going to generate the language, and then we have an automata which is going to accept the language. For regular languages, we have finite automata. For context-free languages, we have push-down automata. For context-sensitive languages, we have linear bounded automata, and then recursive enumerable. For recursive enumerable, we have Turing machines. So this is briefly the hierarchy that should be known to everyone, so that we can solve the questions. So that, because in general, what are the questions? That given a language, you have to identify the class of that language, right? So this is briefly the scenario that we have, right? So what I'll do is I'll briefly take some of the languages and try to give an idea that what are regular languages, although we are not going to make automata for it, because for that we require a lot of time, and this is a very short session that we have. I'm assuming that you know how to draw automata and all, but we will discuss the details which are required to solve the questions that we are going to solve today. So first of all, we are having regular languages. So so when we say, just a second, I'll change the color of the pen. Yeah. So we have, let me take it here. I think yellow will be visible here. Yeah, I think this is fine. Right. So we have regular languages we have with us. So why regular languages are accepted by the finite automata. So when do we say language is regular? We will say that if there is a finite automata which accepts the language, then we can say that the language is regular. So what are the criteria? So first of all, you should understand that all the finite languages that we have, they are regular. So for example, if I fix the number of strings in a language, then I can definitely say that language is regular. So for example, we have L1 here, which is saying that set of all 2-length strings. So what are the 2-length strings that we have? We have AA, we have AB, we have BA, and then BB, given that sigma is equals to A, B, right? So in that case, we have only 4 strings in the language. This language is finite, so we can simply say that yes, this is a regular language, right? So then A to the power P where P is prime. So in general, this language A to the power P where P is prime is a recursive, basically a context sensitive language. But when I have put a constraint that P is less than or equals to 1000, so I have put a constraint. So that this minimizes, this fixes the number of strings in the language. Therefore, I can again say that this language is regular. Then we have, say, L3 is A to the power n, B to the power n. Now again, when n greater than or equals to 0, this language turns out to be a context-free language. But still, when I have put up a constraint, say that n is less than or equals to 1000, then in this case, I can say that the language is regular, because I have put a constraint only there are finite strings in the language, therefore the language is regular. So this language is context sensitive without this constraint, and this language is context free without this constraint, right? How are these things? We will discuss later, but here we have taken these examples for regular languages by putting up the constraints, by putting up the, by fixing up the number of the strings in the language, right? So then we have, so the first criteria is if the language is finite, we will say that the language is regular. Now, if the language is infinite, and if it requires no memory or no comparison, or if it is having finite memory or it is having finite comparison, then also we can say that the language is regular. So for example, we have the example over here where the language is A raised to power n, B raised to power m. So again, the sigma here is A comma B. In this case, I can again say that the language is regular because we are not required doing any comparisons. We don't require any memory. First some A's will come and then some B's will come. So therefore, again, this language is regular, right? So this is briefly 2 criteria. One criteria is when the language is regular. One criteria is when the number of strings are finite. When the language is finite, then we can say that the language is regular. And the other criteria is when we have a finite comparison, or we have a finite memory or no comparison. In such cases, we can say that the language is regular, right? So next criteria is when infinite languages, if there is a pattern and that pattern is in an AP, then we can again say that the language is regular. For example, A raised to power 2n. So that means that a number of A's should be a multiple of 2. So for example, 2, 4, 6, 8. Now this pattern, again 0 can also be here. So this pattern is an AP. So therefore I can clearly say that this language is regular. Over here, the next language is a raised to power 3n plus 1. So that means that the number of a's when divided by 3, number of a's in the string when divided by 3, the remainder that we get is 1. So that means we have the number of a's can be 1, number of a's can be 4, number of a's can be 7, or then 10, and so on. So that again, this is an AP, then again I can say that the string is regular. The language is regular. Right? So when the pattern is in an AP, then again we can say that the language is regular, right? So then we have some infinite languages which require infinite memory. So or infinite comparison, then we can say that the language is non-regular. So earlier we had finite memory, finite comparison. Now we are having infinite memory. When we require infinite memory or when there is an infinite comparison, then we will say that the language is non-regular. So for example, a raised to power n, b raised to power n greater than equals to 0. So we have to compare the number of a's with the number of b's. And this comparison, in infinite comparison, there can be 2 a's, 2 b's, there can be 3 a's, 3 b's, there can be 100 a's, 100 b's, and there can be infinite a's or infinite b's. So this number is infinite. Infinite comparison needs to be done. Therefore, we can say this language is non-regular. Now, if it is non-regular, then this language can be context-free, context-sensitive. Then we have context-free, then we have context-sensitive language, and then apart from this, we also have recursive enumerable languages, right? So we have all these languages. So now, in which category this language will fall? We said that this is a non-regular language, but now which category it is? This we will discuss in the next class. So now, till now, we have discussed 3 criteria. If the language is finite, then we have the language is regular. If the language is infinite, in that case, it should not require any memory. No memory. In this case, we will again say that the language is regular. Now, if the language is infinite and if there is a pattern involved in it, then again we will say that the language is regular. But in case if the language is infinite and it requires infinite memory, then we will say that the language is non-regular, right? So till this point, I assume and I hope everything is clear that we have understood that how to identify that the language is regular or not. Now we will see how to identify a language is context-free or not. So if the language is not regular, it can be context-free also. Then how we are going to check is, first of all, context-free languages are the ones which are accepted by the push-down automata. If you can make a push-down automata for a language, then I can say that the language is context-free, right? And what is the criteria? If a language is infinite and it requires infinite memory or infinite counting, then we can say the language is context-free. But here also we have an important criteria that no more than one infinite comparison should be made at a time, right? So you can have infinite memory, you can have infinite counting, but the number of comparisons that you are doing, you can only do one infinite comparison at a time. If you are requiring more than one infinite comparison at a time, then the language is not going to be context, right? So what we have is, for example, in this case, we have so a raised to power n, b raised to power n. So there we are doing only one infinite comparison. We are comparing the number of a's with the number of b's. So therefore, the language is context. Over here, what we are doing is we are comparing the number of a's in the language L8. We are comparing the number of a's with the number of b's, and we are comparing the number of b's with the number of c's. Now, these are two infinite comparisons which we are doing at a time. Somebody can also say that A is equals to C, we are also doing, but this will come through this, right? If A is equals to B and B is equals to C, we can say that A is also equals to C. So we are doing two infinite comparisons here, right? And if two infinite comparisons are being done, then the language is not context, right? And next is WW. This is again, so where W belongs to AB star, this language is L9. This is also not context free. Why? Because we cannot make a push down automata for it, right? So I'll briefly explain how why we can't make a push down automata. I hope you all know that by push down automata we mean a finite automata with a stack, right? So for example, the string given is to you is ABB. W is ABB, and so what should repeat after it? That is another ABB, right? So this what should be accepted by this language. But if we try to draw a push down automata for this, what we will do is we will push A first, then B first, and now B first. B now after this. So now we have ABB here, right? Now I need to check that the first letter, whether the first letter is A or not. But at the stack, we always have last in first out. We do not know where does we do not have A at the top, so we cannot compare this A with this A. So therefore, push down automata fails here, and this language is not context free, right? So I'm not discussing in detail that how to exactly draw the automata. I'm just giving you an intuition so that you can solve out these questions, right? In detail, if we have to discuss, in general in class we do how we draw push down automatas, how we draw all these details are discussed in detail in class. But here we can only discuss. I'm briefly discussing so that you can solve out the gate questions, right? Then we have So next commonly asked question is that whether the language is deterministic context free or simply context free, that is non-deterministic context free, right? So what we mean by a deterministic context free language is that we should be able to draw a deterministic PDA for it. And if we are able to draw a non-deterministic PDA, then we will say that the language is just CFL. It is not DCFL, right? So CFL is of two types. Either it can be a DCFL or it can be non-deterministic context-free language, right? But both are context-free, right? But for deterministic context-free, you have to clearly say that you are able to draw a deterministic PDA for the language, right? So here is an example. We have W and WR. So WR is basically the reversal of a string. Reversal you can check with the stack. For example, the string is ABB and the reversal is BBA. So you push A on the stack, then B, then B. With this B, you will check this B. With this B, you will check this B. And with this A, you will check this A. So this can be done. And this C will help you to understand that when the reversal is starting. For example, we have C here. Then you can start coping after this point. So since you can do it deterministically, we call it as a DCFL, right? But if we do not have a C in between, then we do not know when exactly we have to start coping. Therefore, the language is CFL, but it is not DCFL. But yes, definitely our stack can handle this with a finite, along with a finite automata. Therefore, it is CFL. So right. So we have discussed till now what is how to identify a regular language. Then we have discussed how to identify a context-free language. Next, what we are left with is how to identify as a context-sensitive language. So this is the last part of this brief introduction that we are going to do. So now we are trying to identify what are context-sensitive languages, right? So we saw that, we saw that we here over here, L8 and L9, they were not context-free languages. Actually, they are context-sensitive languages, which are covered here. So that is L8 and L9 we are repeating here. So I'll briefly explain how they are context sensitive. So yeah. So here you can see. So context sensitive languages are the languages which allow more than one infinite comparison at a time. So earlier we had a constraint that we are only allowing one comparison at a time. Over here we can allow more than one infinite comparison at a time. One infinite comparison, right? So for example, over here in A raised to power n, B raised to power n, C raised to power n, we are doing two infinite comparisons at a time. This will allow. It will allow more than one unit. Therefore, it is a context-sensitive language, right? Now, over here we have linear bounded automata. So basically, what the context-sensitive languages are the ones which are accepted by the linear bounded automata. Now, what is linear bounded automata? It is the Turing machine, and we only allow a linear space, right? Then it is called a linear bounded automata. Now, what we do exactly in linear bounded automata, so in Turing machine, that is, it allows you to go back and forth, and then this way you can check it out. But how exactly Turing machines are made, this cannot be discussed in this small session. But yes, for solving the questions, this much details are enough to understand that yes, when we are requiring infinite comparisons, more than one infinite comparisons, then linear bounded automata comes to it, right? Then WW, again, since we can go back and forth, it gives us a queue. Therefore, we can check WW also here. So this is again a context sensitive language. In this example, L12, so this L12 is after this L11 we have done. So these were the two previous examples. So the next sequence is L12. In L12, we have A raised to power n, B raised to power n, C raised to power n, and D raised to power n. In this case, we can see clearly that so here we can clearly see A raised to power n, B. So we require 3 comparisons at a time. So we have to make a number of A's equals to number of B's, number of B's equals to number of C's, number of C's equals to number of D's. So therefore, again, more than one infinite comparisons, context sensitive language can handle this. Then we have a raised to power n factorial again. So when the patterns are not in an AP, a raised to power n square, a raised to power 2 raised to power n, a raised to power p, then the context sensitive language can clearly handle this. So the context sensitive language can clearly handle all this, all of this, right? So for example, when we say n factorial, it is either for 1 factorial it will be 1, for 2 factorial it will be 2, then 3 factorial will be 6, and 4 factorial will be 24. So again, you can see that the pattern is not in an AP. So therefore, a context sensitive language can handle it. Therefore, I have said that these 3 languages, these 4 languages are context, right? So this is the whole theory which I wanted to discuss before solving the questions. So I hope you clearly understand that what are regular languages, what are the patterns in the regular languages. Then we have discussed in detail that what are what do we say that what are context free languages. We have seen that how to identify these context free languages. We have also seen context sensitive languages and how to identify that the language given language is context sensitive, right? So I hope till this point we all are on the same page. Yeah, okay. So now what we are going to do is we are going to solve certain questions, and as I said, this topic is very heavily asked in GATE. You can find a question in GATE 22 also, and we had some 2 questions last year on this concept. So what we will start solving the questions. So you can see this question. You can start solving this question. We have some 3 languages given over here. And the question says which of the following statements are false. So be very careful with this thing. Sometimes students make a silly mistake here saying that they read it as true and then mark the question wrongly. So it is very clearly written which of the following statements are false. And this is an MSQ based question. So I'm giving you 2 minutes to solve this question and then we will discuss the solution. You can type on your answers in the comment so that I get to know whether you are able to solve it or not, although we will discuss the solution in detail. Right. Yeah. So those who are able to solve the question, they can type the answer in the chat box. So I'm starting the timer. I'll give you 2 minutes to solve the question. So those who are able to solve can post their answers. Yeah. So I do not have any answers till now. Maybe I'll wait. Yeah. I think Abhilash has answered it. Yes. Yeah. I'll just wait for 1 or 2 more seconds if others have answers and then I'll solve it. Okay, so let's solve this question. Abhilash, your answer is correct. So the answer to this question is B, C, D. So all B, C, D are incorrect, and only A is correct for this question, right? So we'll solve the question. So here we can see that clearly, so this language WW, we discussed that it is a context-sensitive language. We just discussed that it's a context-sensitive language. A context-free, a push-down automata cannot accept it, so therefore it's a context-sensitive language. Then A raised to power n, B raised to power n, we are only compare the number of A's with number of B's. We are not comparing the number of C's. This is a context-free language, and at the top of it, it is a deterministic context-free language, right? Why deterministic? Because we can deterministically draw the push-down automata. And then we have, in the push-down automata will be deterministic. Now, A raised to power m, B raised to power n, C raised to power n is again a context-free language. And, sorry. So, and it is again a deterministic context-free language, right? Because only we are comparing with the number of B's with the number of C's, right? Okay. So now, which of the following statements are false? We are saying. So L1 is not context free, right? It is a context sensitive language. But L2 and L3 are deterministic context free, right? Definitely they are deterministic context free. It is just calculated. So therefore A is correct, right? So A is correct. So that means this is not the answer, right? Now, neither L1 nor L2 is context free, right? So we can see that L1 is not context free, that's fine, but L2 is context free, therefore this option is wrong. Then we have L2, L3 and L2 intersection L3 are all context free. So we know that L2 is context free, L3 is context free. Now L2 intersection L3. What is L2 intersection L3? Is A raised to power n, B raised to power n, C raised to power n. This will become L2 intersection L3. Here the number of A's are equal to number of B's. Here number of B's are equals to number of C's. So in the intersection we will have number of A's equals to number of B's equals to number of C's. So this is again a context sensitive language. We discussed here we have to do more than one comparisons, more than one infinite comparisons at a time. Therefore, it is a context sensitive language. It is not a context free language. Therefore, this option is also. Next, we have neither L1 nor its complement is context free. L1 turns out to be a context sensitive language. We have that's fine. So L1 we have as neither L1 nor its complement is context free. So basically L1 is not context free. That's correct. But its complement is also not context free. That's what we are trying to say here. So again, about its complement we do not know. Therefore, again, this option is false. So therefore, B, C, D are all false, and the answer that we get is B, C, D for this question, right? I hope the solution is clear to everyone, right? Okay, so now we'll solve the next question. This is again asked in GATE 2022. It's again an MSQ based question, so more than one answers can be correct. And I hope this was also a very good question. So I'm giving you 2 minutes to solve this question. And yeah, so you guys can try this. Yeah, so those who can solve can give an answer. So anybody could solve this? So I'm waiting for 4 or 5 more seconds so that at least someone answers this. Yeah. Again, I think Abhilash, your answer is correct. Can someone else answer it? I'm just waiting for 1 more second. Okay, any other answers? Okay, so now I'll explain it. So first of all, let's see the what is the answer. So the answer is A, B, and C. All these three options are correct. That L1 and L2 are regular, L1 and L2 are context free, and L1 is regular and L2 is context free. Right? So now let's see how this is correct. So now over here we see L1 is equals to A raised to power n W A raised to power n. Now there is no constraint on n. So n can be 0 also, right? So if I put n equals to 0, so by looking, somebody might feel that you have to compare the number of ways 2 times, then it becomes a context-free language. It is not, it is a context-free language, somebody can say that, right? But again, if you put n equals to 0, if you analyze it closely, you will see that when we put n equals to 0, this becomes L1 equals to W, which means A comma B star, A plus B star, right? And this is basically the universal language that we have. So this language is a superset of all the languages that we can make out of A comma B. So since L1 involves in L1 has W, and all other languages that we have which are subsets of it, by keeping n equals to 1, n equals to 2, n equals to 3, and so on and so forth. So we can say that this language is regular. Right? That is part 1. So this language is regular. L1 is comes out to be regular. Now part 2 is WHWR. Now W is there with us, and we have the reversal of W over here. This is the second string that we have, right? Now, so first of all, we should have W, and then we should have X, and then we should have the reversal of W. Now again, somebody might say that we have to check that the reversal of W, therefore this language is context free. But no, this also comes out to be a regular language. How? Let's see. So here, WXWR. What we are trying to do is we are trying to expand X till the last point, and we'll leave only again. So since W and X both are AB star, So therefore, we can expand x as much as we can, and we can make w and wr both as epsilon. Right? If I keep w and wr both as epsilons, and x will engulf the entire string, right? And since x can become a plus b star, ax can be a plus b star. So this again turns out to be sigma star, which is regular. So what we calculate is L1 and L2 both are regular. So now let's see the options. So we say L1 and L2 both are regular. Yes, they are regular. L1 and L2 both are context free. Yes, something which is regular is also context free. We discussed that context free is a superset of regular languages. So every regular language is also a context free language. So therefore, yes, B is also correct. Next is L1 is regular, L2 is context free. This is also correct. Because L1 is regular, L2 is also regular, but since it is regular, it is also context free. So A, B, C, all three are correct. Now for D, we have L1 and L2 are context free, but not regular. Over here, we see the option is wrong. They are context free true and they are regular true. So this is wrong. So therefore, the answer that we have is A, B, C. That is L1 and L2 are regular, L1 and L2 are context free, and L1 is regular and L2 is context free. So I think, Kirti, there is just one mistake in your answer. You forgot to calculate C, right? Yeah. So I hope everybody could understand and follow this answer. Yes. Okay. Right. And yes. So right. I hope the solution is clear. Can somebody comment and say that whether it is clear or not? Yeah. Kirti, is the solution clear? Can you say so that I get to know that whether people are on the same page or not? Yeah. Okay. So right, I think till this point we discussed two questions which were asked in the last gate. Over here, I hand-wavily said this thing. So in the previous question that I showed, I said L1 is a context-sensitive language, so it's not context-free. And its complement, I said, is we cannot comment about its complement, so therefore we said this option is false. But again, we can explain it in a better way also. I just hand-wavily said that yes, it is not context-free. So basically, let's see what does its complement looks like. So for example, we have L1 as WW. What will be the complement? So the complement of L1 will be W and some W prime, where W prime is not equal to W, right? So what I can do is, in this W prime, I can put W prime as epsilon, and W can be my sigma, which is sigma star, which is A plus B star. So this language engulfs everything. A plus B star concatenated with epsilon, we get another A plus B star, right? So therefore, this language turns out to be regular. So it's definitely context free also, right? So since it is regular, therefore this option is false. Its complement is context free. It is saying its complement is actually, no, its complement is context free. That means the complement is not context free, but no, it is context free. It is regular. So since it is regular, it is also context free too, right? And in this, there is a small small trick over here. So for example, somebody might say that yes, sir, your W can also be epsilon. So right, that case is also there when W dash, where W dash is epsilon, W can also be epsilon. This string we have to omit. So that means it is A plus B star minus epsilon. Then we can say that it is nothing but A plus B plus. This is also what do we say? It's a regular language, right? So therefore, since its complement is not context free, it's basically its complement is actually regular. Therefore, this option is. So I didn't explain it in detail. So therefore, I explained it again to you, right? So this was the previous question that we discussed, right? Okay. So I think we solved both the questions of GATE 2022 which came on this subject, on this topic particularly. So now let's solve one more question, that is GATE 2021 question on the same subject, on the same topic that we have. So I'm again giving you 2 minutes to solve this question. Please try this. And I hope people are getting the things in a proper way. So if there is some confusion, you can write down in the comment. I'll explain that again to you. Yeah. So you have 2 minutes to solve this question. Let's see who can answer this. So it's again an MSQ question, so multiple answers will be correct, right? So you have some 4 languages and you have to tell which of the following languages are context free. So, okay, Abhilash has an answer. I expect answers from others too. I think till now Abhilash is answering and he has very good. He has answered all the 2 options correctly. I will see Abhilash the answer for this question, for the third one. Others, I'm waiting for your answers. I think I'll give one more 4-5 more seconds to solve. I'm waiting for others' answers. Yeah. So which of the following languages are context free? You have to identify the context free language. So as we saw that every year we have a question on this. We have 2022, we had a question on this. And then we had a question in 21 too. Yeah. Okay. Should we go ahead with the solution? Okay. So the answer to this question is again BCD. Abhilash, your answer is correct. So we have okay. So let's solve this. Which of the following languages are context? We are trying to find out which languages are context free. Here we have. So let's start. I think this language we just discussed. WX, WR. Option C we just discussed that X can engulf everything and my W and WR can become epsilons. So then L becomes equals to sigma star. So therefore it is regular. So something which is regular is also context free. So therefore option C is correct. So why I took this option first because we just discussed this. Then we have over here the B option says that W, WR, X, XR. Right. So here you can clearly see that initially you have to check W and then you check that whether there is a reversal of W. This can be done by the push down automata. We just discussed this. Then X and XR again we have to just check the reverse. So first you check W and WR and then you check X and XR. So this is again context free. But please find it, this is not deterministic context free. Although this is not asked in the question, I'm just giving an extra information because you do not know when the reversal of X starts, when the reversal of W starts. This is not deterministic context free, but this is a context free language. So therefore, again, option B is the answer. Now, let's see option C. It says W, since BCD is the answer, I'm looking at those options first. W, X, XR, and WR. So again, over here, what you can do, you can push W. Although W is not just one, there are various alphabets in W. And then we push X, and then we check the reversal of X with XR, and then we check reversal of W with WR. Again, this becomes context free. And to add to your knowledge, again, it is not a deterministic context free language, but it is context free. Since it's context free, we can say that this is our answer. Now, what is the problem with this language? Why it is not context free? So here we see that L is W. We put push W. We push X. Now we have to check WR. How would we check reverse of WR with respect to W from this language? Since we have X at the top. So X and W, by the way, they are not just one alphabet. They are a series. This is the strings, but again, for the semantic purposes, for that, I have shown it to you like this, right? Okay, and then again, XR also cannot be checked. So this is not a context-free language. So the answers are B, C, and D. I hope the solution is clear to everyone. Yeah. So this is GATE 2021 question, and now let's move to GATE 2020. So GATE 2020 also had a question on this regarding the for finding out the type of the language. So again, I give you 2 minutes to solve this question. This seems to be a pretty easy question. I think you should be able to solve in less than 2 minutes. So this is an MCQ. So now only one option will be correct. And I think you all know MCQ got introduced in 2021 only. So 21 and 22 we had MCQs, and from 2020, if we go behind in the years, we will only have MCQ questions. Yeah, please go ahead with this. So I think only Abhilash is able to solve the questions. I expect answers from others too. Please do try. And at least to whatever point you reach, you could at least answer that much. Like the nearest guess. So we'll extend the session a bit, at least. So I want everyone to solve at least 10 questions. So we'll solve 10 questions and then close the session. We might extend it by 15-20 minutes. Because that will give you a clear picture and that will solve the purpose of the session. Yeah. Okay, till now we don't have any answers. I'll wait for some more time, for 5 more seconds for you to solve it. 5 more seconds. Yeah. Okay. So any guesses also, I think guesses will also work so that I can start solving the question. If anyone wants to guess the nearest answer, whatever they could solve. Okay, I think we have an answer. Answer is A. Yeah. Any other answers? Okay, so let's solve the question. So the answer is correct. The answer is A. That is first and third only. So let's see how it comes out. Okay, so here we have the language is Kirti. Yeah, small mistake. I think you missed the third point. Otherwise, your answer is correct. Abhilash, your answer is correct. Yeah. So Deepak, no. I think the answer is B. Yeah. Yeah. So let's solve the question. Okay. So we have the language L is a union of two languages. One language is A raised to power n, which is definitely regular. Now the other language is A raised to power n, B raised to power n, which is a context-free language. We just discussed in the theory that we discussed. Now it says that the language L is deterministic context-free, or what it is. So I think it says one option says it is deterministic context-free, and the other option says that it is context-free but not deterministic context, right? So okay, so now we have to understand that whether it is context-free or it is deterministic context-free. Now see, over here we have A raised to power n, and then we have A raised to power n, B raised to power n. So now how do we identify it is deterministic context-free? By drawing a deterministic push-down automata. In the theory that we discussed in the beginning, we saw that if we are able to draw a deterministic PDA, then we can say the language is deterministic context-free. Now for this language, it turns out that you can draw the deterministic PDA. How? So for example, I'll briefly draw the PDA, and I hope you know the basic details about PDA. So here, till the point A comes up, you are able to accept it. Now, and you are also pushing up the number of A's too. So on the stack, what you will do is you will push the number of A's. Just a second. You will push the number of A's on the stack. What you will do is if A comes out, then Z0, A, Z0. And then A, and if A is already there on the stack, then AA. But why have I made it as a final state? Because A raised to power n is also acceptable, right? Now when B comes out, you start popping, right? So it will be, you replace A with epsilon, right? If B comes up. And you keep on popping B till all the A's are exhausted. So, right, A and epsilon. You keep on replacing like this. And then finally, if you reach epsilon and the top of the stack is Z0, then you keep Z0 and then you reach the final state, right? So this is briefly you can draw how you can draw the deterministic PDA, and this PDA is deterministic since you do not have a confusion that where to move when, right? So therefore we can draw a deterministic PDA for this language. So therefore it is deterministic context language, right? So I think L1 is a deterministic context-free language. This is fine. Now L1 is not LLK for any K. Now when we say LLK, so again, so this means that after what point you are able to determine that which of the productions is to be used, which of the production is to be used, right? Now over here you see A raised to power n, and then it is A raised to power n, B raised to power n. So after n points, you'll be able to tell that whether you have to use this language or whether the language is this. So, and this n is infinite because n is greater than or equals to 0. Therefore, you cannot surely tell that at what point you can, there is no short point that where you can tell that yes, this language is this and this. Either you have to use this production or you have to use this production. Therefore, it is not LLK for any. So answer both A and 1 and 3 are correct. So the option is A, right? So I hope people could understand the solution, and I am assuming that people know that what a deterministic PDA, how to draw PDAs, and I just briefly draw the sketch of this PDA, that how this PDA looks like, right? Okay. So next we'll solve another question. I think GATE 2021 we had one question. GATE 2020 we have a question on this. So we have solved two questions on 2022 and one question on 21. And this is the question for 2020. I think 2020 we solved one question already. So this is the second question from 2020. Yeah. So I give you 2 minutes to solve the question. Just give it a try. So now the questions will be MCQs. Now I think your guesses will also work. MSQ makes it tough to guess. So if somebody is able to reach to some point and have a guess in mind, they can also comment on this. Yeah. So I think this option is a bit less visible. This is L2 is context free. This over here we have L2 is context free. Option D, I think because of my picture, this is not visible. Anybody could solve? I'll wait for at least one answer. Yeah. I think Kirti, Deepak, and Abhilash, please be a wild guess will also work, but at least some guess, not a wild one. At least, which is, at least I think you could solve one of the languages and then you can guess. Abhilash is D. No, I think you are wrong this time, Abhilash. D is not the answer. You can change the answer to if you, based on my inputs, if you think that yes, something else should be the answer. Okay, I think we'll solve the question because, okay. So here we have which of the following is true. And the answer to this question is A, L1 is regular and L2 is context free. Now, I think Abhilash said L1 is context free. I think it is regular. That's why there is a problem. And L2 is context free. Yes, you are correct. So I think L1 you could not calculate properly. Let's see how we can calculate. So here what we are trying to say is W and Y can be a 0, 1 star, 0 plus 1 star, but X has to be matched with X. And I think you thought that we have to match X with X. Therefore, it will be somewhere around context sensitive too, because in context sensitive only you can check this X, you can match X with X. But no, over here, if you closely observe this language, as I did previously also, so Wx, Yx we have, you expand W till the point only one letter in X is left, only one alphabet, sorry, only one symbol is left in X. And you expand Y till the point that only one symbol is left in X, this X also. So that means you have to only compare two letters, two symbols. You can write this language as, so this X can be 0, 0 also, or it can be 1, 1 also. So how you can write this language as, it is 0 plus 1 star, 0, 0 plus 1 star, 0. Or it can be 0 plus 1 star plus 1, 0 plus 1 star, 1. Right? This is briefly this language, what this language can. Right? And since we can write a regular expression for the same, this language is regular. Right? So so we are comparing two X's with themselves. So something which has, so all other languages are a subset of this language. So for example, somebody can say that there are two letters are same, sir. Yes, 0, 0 is same, or 1, 1 is same. So if two letters are same, at least one letter will also be same, right? So that language is a subset of this language, right? So this universal, so this bigger subset which I have written is regular, and all other languages are a subset of it. Therefore, we can say it is regular. So how to solve these kind of questions? This question is very heavily asked in GATE. When we have to expand the language, always think the worst case. Always think the worst case, and think in terms of the language, that whether that string is in the language or not, in terms of the language. Try to expand first as much as you can so that the comparison part you reduce to the maximum. And then think in terms of the language, see that does the worst case engulfs everything, all other languages, then you can say that the language is. So I think this is the trick to solve these kinds of questions. And this, if you apply, you'll be able to solve these questions very easily, right? Now the next language that we have, XY. x comma y belongs to AB star, and where mod of x is equals to mod of y and x is not equals to y, right? And this is also a very wonderful question. Over here you can see that they are saying mod of x has to be equals to mod of y. So first of all, understand that if the length of the string is odd, so what we are doing is we have a string, say some string in the language, and we have to divide it into two parts. That's it. That's what it is. X dot y, right? Now we have to divide the string into two parts such that mod of x is equals to mod of y. So for all even length strings, we can do that, right? If the length is 6, I can divide it into 3, 3. If the language is string length is 8, I can divide it into 4, 4. And if the string is 9, say, if it is odd, then you cannot divide it. So all odd length strings are out of the strings. Only even length strings are there in the language, right? But at the top of it, we also have to compare x with x should not be equal to. So whatever is there in the x, you have to compare with y that x should not be equal, and this comparison cannot be done by a regular language, right? A regular language cannot do this comparison. We require a context-free language. We require a automata to solve this. So therefore, what we can say is we require an automata. We require a stack to solve it. So therefore, what we can say is L1 is regular and L2 is context-free. We have to compare that these two things are not equal, right? So therefore, it is context-free. It's not regular, it is context-free, right? I hope you all could understand the solution. So we'll solve the question from GATE 2019. I think we solved 5 questions, and I think this question is from 2019. 2 from 2022, 1 from 2021, and 2 from 2020 we have already solved. So let's do this question on 2019. And this seems to be a pretty easy question. Yeah. Which of the following languages over sigma equals to AB is not context free? I think for this, I assume that many will be able to answer. Please try this. At least one or two of these we have already discussed in the theory. So they are directly from the theory. Okay. I think this should be solved quite fast. I think 1 minute is enough for this question. But again, so yeah, Abhilash, your answer is correct. What about others? Please solve it fast. Yeah, I think we have only one answer till now. Others can please tell their answers. I think Kirti and Deepak, what are your answers? I think this you should do it fast because it's an easy one. Okay. Okay, so I think we'll solve this. So the answer to this question is B, as I think Vilash answered it also. Okay. So again, WWR we discussed. It's a context-free language. This we discussed in the theory itself. Since B is the answer, I'll discuss it at the end. So Kirti, I think this is the MCQ question. There cannot be two answers. So yeah. Okay. So then we have A raised to power n, B raised to power I. So I'll discuss it at the end since it's the answer. So A raised to power n, B raised to power I. So here we have to compare the number of A's with number of B's. This we can do because this is again for every one A, I will either push one B if it is n. If it is 3n, for every one A, I'll push 3 A's for every one. So I'll push 3 A's instead of one A. And here I'll push some 5 A's for every A. And then B's I can pop out. So again, this will be a context-free language. Right? And then we have, say, again, but it will not be a deterministic one because in the beginning you do not know. So when you draw the push-down automata for it, it will not become out to be a deterministic one. But this is not asked in the question. This is, I'm just adding it to your knowledge. Okay. So now A raised to power n, B raised to power n, and WWR. Over here you can see that what you can do is you can push A first, W first, and then A first, and then A after it. Then you compare the number of B's with number of A's. You pop B for you pop A for every B, and then you match W with WR since the string is available in reverse. So therefore, it is again a context-free language. Now, what is the problem here? Here, if you push W first, then A will come at the top. Then we have WR. Now, WR is basically, how would we check W with WR when A is at the top of the stack? So again, we cannot do it with a push down automata. Therefore, it is not CFL. In fact, it is context sensitive. So therefore, B is the answer. Right? So I think, yeah. So answer is B. Yeah. So next we have the question from 2018. So this is the 7th question which we are doing today. We are left with what 3-4 more questions, and I think then we'll close this session. So I think we'll briefly extend it. Okay. So I give you 2 minutes to solve this, and then I'll solve it. I think this I expect, I think others should also be able to do. Everyone should be able to do. I think people can also solve it by the help of elimination also. You can eliminate certain options and then you'll get very near to the answer. Any answers? Okay, time is up. I think, okay, Avilash says B. What about others? Okay, I think we'll solve it now. So the answer is to this question is B only. That first and second languages are context. The others are not context. Right. So again, I think we can also try through elimination. So for example, over here you can clearly see that we are doing three comparisons at a time, or maybe two comparisons at a time, because we can compare M with N and N with V. Two infinite comparisons are not allowed in context free. So third cannot be the option. So I think we can simply eliminate this one, right? Now, Mn is equals to P plus Q. Now, again, this multiplication business, how would you do that in a stack? So this cannot be done with the help of a stack, this multiplication business. Again, this cannot be done. So therefore, it is a context. It's not a context-free language. So again, you can eliminate the fourth option. So this also says fourth. This also says fourth. We are only left with B. So the answer is B. So this can be done with the eliminations too. But again, for the sake of clarity, I'll solve it fully for you guys. So over here you can see that what is it saying? M is equals to N and P is equals to Q. This is also okay. This is okay. First you will compare M with N, and then after that, that comparison is done, then you will compare P with Q. So therefore the answer will be context free language. And this is also a context free language. Why? So what you will do is you can push A's first, then B will pop A's. So since B comes here, so this is A's, this is B's, this is the number of B's, this is the number of C, and this is the number of D. So your how will your push down automata looks like? You will push A's, then pop A's with every B. Then you can push C, and then you can pop pop C with every D. So this you can do easily. So therefore it comes out to be a context free language, right? So in this case, I assume that it might also happen that the B's are more than A's. In that case, if you have more B's, then you push B's also. So like again, this automata, you can draw clearly this push down automata. So we do not have that much time to draw this automata completely. This is a brief sketch which I gave it to you. You have to consider other cases also. This case assumes that the number of A's are greater than number of B's, and number of C's are also then right. This assumes that number of A's are greater than B. But if it is not, in that case, you also need to push B also, and then you can draw the sketch further. So I'm not discussing that in detail, but I just gave you an intuition that how it is a context free language, right? So I hope this is clear, right? Yeah. So now let's discuss next question that we have. This is the 2017 question that we have. So I think this is, I give you another 2 minutes to solve this. And I think this is pretty easy question. This should, everyone should be able to. We all already discussed a lot in the theory. I think 1 minute should be sufficient for this question. So I'll give you another 30 seconds and then I'll solve it for you. If this question doesn't require 2 minutes. Avilash, your answer is correct. Good. Any other answers? Okay, we'll see the answer. So the answer to this question is A. And how it is. So again, as I said, you have L1 as A raised to power n, B raised to power n. So again, you are comparing number of A's with number of B's. That's it. That's one comparison. Therefore, it is a context-free language. Now here you are comparing the number of B's with number of C's. Again, there is just one comparison. This is a context-free language. And if you have listened to theory, you know why it is context-free, right? Now, which of the following are context-free languages? That is what is asked. So union. So L1 unioned with L2. Again, so context-free languages, they are closed under union. So therefore, L1 union L2 is a context. Now, what about L1 intersection L2? L1 intersection L2 will be A raised to power n, B raised to power n, C raised to power n. Because how it is A raised to power n, B raised to power n, C raised to power n? Because here in L1, number of A's are equal to number of B's. In L2, number of B's are equals to number of C's. And when we do an intersection, it is number of A's is equals to number of B's is equals to number of C's, right? That's what it is. Right? So therefore, what we can say is, we are doing three comparisons here, or two comparisons. We are comparing with the number of A's with number of B's and number of B's with number of C's. So therefore, two infinite comparisons, this is not context. So only A is the answer, that is, it is context. L1 union L2 is context. That's it. Yeah. Okay. So in 2017, two questions were asked. This is the second question on the type of the language. So I give you another 2 minutes to solve this. Yeah, I think Kirti and Abhilash solved the previous question correctly. Great, good. So I think this also is a pretty easy question, but I give you 2 minutes. But if somebody could solve it in less than 2 minutes, that's really great, because this is also very easy. Yeah. So we'll do just after this, we'll do one more question and then we'll wind up the session. By that, we'll be able to solve 10 questions, right? So as we decided, we'll solve 10 questions and we'll discuss a brief theory. Both will be done. So Abhilash says D. Okay, Abhilash will check. Any other answers? Okay, we'll solve this now. Let's see what is the answer. Answer is D only. Right, good. So D is the answer. Let's see how it is. So over here, let's see what is the type of each language, and then we will evaluate each option. A raised to power P, P is the prime number. So again, as we discussed, it's a context-sensitive language. It says L1 is not context-free. L1 is context-free but not regular. So this cannot be the answer, right? So L1 is actually context-sensitive. So by this, we can eliminate this option and this option. So we are only left with two options which can be correct, right? And then we have A raised to power n, B raised to power m, C raised to power 2n. So again, number of Bs have to be compared with number of Cs, and we will push 2 Bs for every 1 B. And then we can compare the numbers. So this turns out to be a context-free language. And it says L2 is not context-free. This is also false. So if second is false, this option also goes away. We are only left with the one option, which is D, which is correct. So I think we can smartly solve it. We don't need to even look at the other languages. But again, for the sake of completion, I'll do it for you. Next is L3 is not context-free but recursive. Yes, definitely it is not context-free because we have to compare A with B and B with C. So again, lot many comparisons are needed. So this is a context-sensitive language, and every context-sensitive language is recursive. So therefore, it is recursive. We discussed the hierarchy. Regular, then we have context-free, then we have context-sensitive, and then we have recursive. And the last one is A raised to power and B raised to power n, where again it is a context-free language. We discussed it in the theory. We have to compare just with the number of A's with the number of B's, and it is deterministic context-free also. We can design a deterministic VDA for it, right? So therefore, option 3 and 4 are correct, and we have option D is the answer, right? So last question for today's session, which completes 10 questions, and you can see the frequency. We started from the back from 2016. 2022 we started. Till 2016, we find out 10 questions on this. So this is a very heavily asked topic in GATE. Yeah, so I give you just 2 minutes to solve it, and with this question, we'll end the session. Yeah. You should be able to do it in 1 minute because it's very easy. Any answers? Kirti says B. Kirti says B. Any other answers? Okay, we'll solve this. At least we have one answer. Okay, so the answer is B only. Yes, Kirti, your answer is correct. And let's solve this question. So it says two languages, which of the following is true? So so over here you have to compare the number of A's and B's, the sum of the number of A's and B's with C. So what you can do is you can push A's, then you can push B's, and then for every C you can pop B or A, whichever is there. So then through a push down automata you can do it. Therefore you have it as a context-free language, right? So right. And then over here, we have to compare number of A's with number of B's and also with number of C's also. So this, again, there are two infinite comparisons at a time. I discussed this in the theory also. Therefore, it is not a CF. So L1 is context free and L2 is not context. Right? So I think B is the answer for this question. Yeah. Yeah. So I think by this we can we wind up with this session, and I think in the last 1.5 hours, what we did is we tried to understand what we say as what are the various classes of languages we have, and we also discussed that how we can basically identify the class of the language given a question. And I think I gave a brief overview of the last 6-7 years questions which were asked on this topic, and right. And I think in detail, how we draw these things, I assume that you know already that what is what is the finite automata, what is a push-down automata, what is a linear bounded automata, what is a Turing machine. I assume that you all knew this stuff, and this is briefly how we could solve this. Yeah. So I think with this, we will wind up this session. I hope you guys enjoyed this session, and we'll see you in future too with more sessions on theory of computations.